Hello, I'm Anna Mackay, and in this video we're looking at two things: collinear points and ratio of division. So collinear points to start with. By the way, have you ever thought about the word collinear, breaking it down to the two words that are there? You've got linear as the second part, and within that is line, so we're talking about things in terms of lines, and co usually means collaboration, working together, so together on a line, that's what we're talking about. So these points are collinear if this fact is true, that the vector AB is parallel to vector BC, so they have to be parallel to possibly be on the same line to start with. Just breaking that down, you could have a few different versions of that if you like. Notice that each time around one letter is repeated. So A in that case or the C in that case, so either of them could apply. And also, one of them must be a scalar multiple of the other. So in this case here, we've got AB is equal to K times the vector BC. Let's put that into practice with an example here. We're asked to show that those 3 points are collinear. So how do you do that? By looking at this fact here that we said, let's identify what vector AB is. So AB is equal to, where you start with the vector B first, and we're looking at the first component, the horizontal component, the 6. So we have square brackets, 6 subtract 1, because that came from that part of A, comma. Now you're looking at the second part of the vector, the vertical component, and you look at B first, 13 subtract 11. That comes out to be 5, 2. And now let's look at the vector BC. So for that we start with C, so we're looking at that 16 and we're subtracting off 6, so it's the difference between those two horizontal parts, and 17 subtract 13 leaves us with 10, 4. Now to be collinear, we have to have vector AB is equal to K lots of BC. So essentially we're trying to work out, well, what is that K value? So you look at the component here of BC, sorry, the vector BC, and let's look at one component, that 10, and ask yourself, okay, well, what do I have to times that 10 by a scalar to turn it into the component from the first vector, to turn it into that 5? And then that's some simple rearranging, that K is equal to 1/2. So each time around you get one of these problems, you look at the components and just start with one, so just pick one of them. I pick the X, and you say, well, what scalar would I have to multiply that to turn it into the other vector, and rearrange that to solve for K. And therefore that's your K factor, and over here we can finish off that 1/2 of BC would be equal to the vector AB. And by showing that, you've satisfied the requirements to prove that they are collinear. Second part, ratio of division. So if we have a point P and it's lying on the line AB, then we can say that P divides AB in the ratio of, written like this, so AP to PB is what we say, separated by a colon there. So there'll be two numbers either side of that colon. We're going to do one example. If we're given A and B, so imagining they're 2 points on a line, we have to find point B, which divides that line into the ratio 2 to 5. When we do one of these diagrams, we must always include the origin. So here's the technique to solve these questions. Hope you've got a ruler handy. So we're going to draw a diagram. Now, you don't have to imagine where that would be graphed if you were to draw it properly, with an X and Y over at -3 and up to. You can do that if you'd like, if you feel it would help you. But for here, let's just draw a sketch. So I'm going to draw the line like this, and I'm going to put on what I know. I'm going to put on A and B. And then I'm going to think about how this line's divided up, 2 to 5. So that means from A to P would be 2 parts, and from P to B would be 5 parts. How many parts is that in total? 7. So imagine dividing the line AB up into 7 equal parts, and after 2 of them, that's where you'd put P. I'm going to go along and finish off my diagram now. And the last part of these diagrams is to have an origin. There, we'll call that O. Okay, so you ask yourself, okay, I need the vector OP. Well, I don't have that information. Is there any other way I could go from O, begin at O, and end up at P? Well, there is. If I started at O and went across to A, and then from A to P, that would be the same as the vector O to P. So let's write that out as a start. That vector O to P is the same as going from O to A and then A to P. So what else do I know about this? O to A I do know, so I can write that in a minute. What about A to P? Well, I don't know what P is, but I do know A to B. I could work that out because I've got information about that. And I know that from A to B is 2 parts of that line. So our scalar there we can create of 2 out of how many parts in total? It was 7 of the line AB. So now I've got 2 things which I can work out. O to A is the vector -3, 2. And we're going to add on 2 out of 7 lots of the line AB. What is AB? I'm going to have to do a side calculation for that. So off to the side here, I'm going to work out AB. And that's where you take B first, the 5, subtract that -3. But therefore it becomes a +3, and the vertical component is -1, subtract 2. Working that out, I get 8, -3. So that is AB. I'm now going to put that back in over here where I need it, 8, -3, and I'm going to carry on working this out. Okay, so you're going to add together the relevant components. So here I'm about to add on 8 multiplied by that 2 on 7. So feel free to go ahead and do this if you can speed it up yourself. And then the second part is 2 from the OA, adding on 2 over 7 multiplied by that -3. So it becomes a negative here, 6 on 7. And our final answer, tidying that up, is this is for the vector O to P. Is that. Go back and read the question though. It did say to find the point P. Currently that's in the form of the vector. So it would be good etiquette to write that out as a point. Good. Join me in the next video in this series, Problems with Vectors. Subscribe to the channel if you haven't already. Thanks for watching.